Alright, so here we are on our next section of Chapter 1. We're talking about midpoint and distance in the coordinate plane, so it just means in a graph. Alright, so what's going to happen is sometimes our segments, which we have already been talking about drawing, are now going to end up being on a grid. Okay, so our segments have moved to just a blank plane to a grid plane, but either way, a flat surface. So we need to use what we know to determine where the midpoint of the segment is on this coordinate plane. Now most of the time what's going to happen is you are going to end up kind of using a slope idea, right? So you're going to see that what happens is you go down 1 over 1 to continue this line, down 1 over 1, down 1 over 1, down 1 over, 2, that's what we're doing there. And so because you see that, you have 4 movements, and so right here is going to have to be your middle, or your midpoint. Alright, so whatever strategy it is that you might use to figure out that that is the middle of A to B is perfectly acceptable. Maybe you thought, oh, there's like 2 here and 2 here that I go diagonal, and 2 and 2, or maybe you counted all the way up and over and talked about dividing that in half. Whatever it happened to be, our midpoint is going to be the coordinate 1, 3. So in order to get the midpoint from coordinates, okay, so let's say that we're using again this same idea. We know the answer is going to be 1, 3. If we end up using coordinates, we're going to have a formula that we can kind of discover. So for instance, we know that our midpoint is 1, 3, and so taking a look at our x's and our y's here, how might you go about getting a 1 from a combination of 3 and, 3 and 5? And so if you look at it, the distance between 3 and 5 is going to be 8 pieces. But then if you want halfway between that, there's 4 of them. So what do we call something about 2 numbers that we're putting together and then taking half of? And that would be an average. So I'm going to take -3, add it to 5, and divide by 2. And I realize that that average becomes 1. I'm going to do the same thing for the other point, so thinking about how we got to 3 from 5 and 1. Well, if we take the 5, that's the height of the first one, and 1, that's the height of the second, and average, we're going to end up with 3. So that's the idea of how we're going to get the coordinate point. And so when we look at applying this piece to actually using just variables, what you're going to end up with in order to find the midpoint is taking the average, right, of all of the x's being added, so the first x, whatever that happens to be, plus the second x, and then the first y and the second y. But again, if you can't remember the midpoint formula, just remember that it's the average. Alright, so this is officially the midpoint formula. It will be given to you anytime you need it on a quiz or a test, but you could also just say, hey, I know that it's average. Here's it written nicer, super. And then we have our distance or our length, and I did mention this a few times in our previous notes, but distance or length is, for some reason people have problems interchanging between the two, but they are the same. So if I ask you the length of something, you're not going to think of the distance formula usually, which is weird. So again, length, distance, how long something is, that's going to be all this same idea. So, first thing that we're going to do is use what we know to determine the length of this segment. So, this is where I tend to get a lot of people that try to count diagonally, which is a little bit difficult. So, for instance, you might think, oh, well, I've covered kind of 2 squares to get from here at A to here. another 2 squares to get here, another 2 squares I guess I'm crossing, and then another 2, and so maybe this is a distance of 8. Okay, but we aren't ever going to talk about counting things across diagonally, especially because even if I did count the fact that this is a square, this distance across is actually longer than the side length, so we're actually not even counting that as one distance. So either way, again, not going to necessarily use that. Now, if we wanted to estimate, that would be a perfect idea, but we're not going to be doing that. So we're going to use what we know to determine the length of this segment. And so what I'm going to do is end up making this into a shape that I am familiar with. So hopefully you've seen a right triangle. And you may actually know how to get this side length over here from a right triangle. So if we know that this side is 1, 2, 3, 4, 4 in length, and we know this side is 8 in length, this from A to B is the longest side, and so it's actually going to be more than 8, thinking back to that estimation that I had. And maybe you remember that if this side is the shorter one, and this one is the longer one, of the legs, and then this one is what we call the hypotenuse. You may remember the formula, which I'll show you on this next slide, is a squared plus b squared equals c squared. So when we look at this here, trying to find that distance, I know that I'm going to take 4 and square it, add that to 8 and square it, and that's going to end up being my hypotenuse, which we usually denote as c squared. So algebraically, that means that I could solve this and get 16 plus 64 equals c squared, or the fact that it's 80 equal to c squared. And of course, because of square roots, to solve this, our c value is actually going to be a decimal. Let's find out what that decimal is. Boop. 8.94. So, again, guessing that it was a length of 8 because we diagonally counted. Again, not really what we're looking for. So, now that we know our distance and length of this segment can be used with the Pythagorean theorem, we're actually going to figure out how, other than counting the fact that there are 4 squares to make up that side and 8 squares to make up that side, we're going to find out algebraically how we can say that we got 4 and 8. So taking a look at the coordinates, how do you get 4 from this height of 5 and this height of 1? And so hopefully you can see that we're going to end up getting 4, which we wanted to square in our formula, and then we had an 8 squared in our formula to make c. That 4 is going to come from 5 minus 1. To that, we're going to add this 8, and that 8, especially if we look at the number of 5 and negative 3, comes from 5 subtracting negative 3. So 5 subtracting negative 3, and then that would be an 8 that we'll end up squaring. So ultimately what we've done is subtracted the highest and the lowest values, and then also the leftmost and the rightmost values, and that's how we would have got 4 and 8. Again, we did initially get them by counting, but now we can actually get them by subtracting. So moving a little bit further from this statement, we're now going to see if we can actually use it with a coordinate point. So if you remember how we did it over here, we were doing 5 minus 1, which was this point here and this point here being subtracted. So in that case, we're going to take this point here and this point here and subtract them. And that is going to be squared one of our side lengths. Okay. Then the next piece is going to take another set and subtract them. So looking back at our previous example, we had a 5 and a 3 that we ended up subtracting. So we're going to take our 5 minus 3 and subtract them. Now, as I'm looking at this, especially because of subtraction and then also squaring things, it turns out that I tried to make this one positive and this one positive, but the glory of squareds is that it doesn't actually matter if either of them is positive, because once you subtract them and square them, they'll all end up being positive. So, in that case, I'm going to actually rearrange this so that it's a little bit nicer to look at. So in that case, instead of an x with a little 2 here and then a 1 here, I'm actually going to do x1 and then 2. So if we look at the order of how this goes, the first y value, the second y value, the first x value, and the second x value. And then we're going to say that that would potentially have equaled c squared, or your hypotenuse. All right. Turns out that we're trying to find a distance, so rather than saying that this equals the distance squared formula, because that seems like unlikely, we're going to undo the square. So if we undo a square, we're going to undo a square to this side. So I officially have that c, or my distance, is going to be the square root of taking my y's and subtracting them, squaring, and my x's and subtracting them. Oops, that's not an x, that's a y. Subtracting and squaring. If we take a look at the actual formula, here it is. They have x's over here and y's over here, but hopefully remember that addition is commutative. So really the only difference is going to be that you just need to take your x's, whatever they are, and subtract them, your y's, whatever they are, and subtract them, and then continue with that Pythagorean theorem. All right. So those are the two formulas that you're going to be using on the assignment today. Tomorrow when you get it, or next Monday.